Alrighty, we did similar polygons. Now we're going to get a little bit more specific with similar triangles. Think about what similar means. Means same what? Shape and different what? Size. Remember, the corresponding angles have to be congruent and the corresponding sides have to be proportional. All right, so how can we prove that two triangles are similar? Remember those side angle, side angle, side angle, and all that when we were proving triangles congruent? Well, we have similar ways of proving similarity. We don't have to go through all 6 parts, all 3 angles and all 3 sides. We can use just 2 parts. Angle, angle, similarity. What do you think that's going to say? It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then those triangles are similar. So all we have to know is 2 angles. We don't have to know any sides at all. If these 2 are similar or congruent, to these 2, then obviously the third one has to be the same because I got to add up to 180. Okay? So therefore, these 2 triangles are going to be similar. So let's write a similarity statement here. Again, watch your corresponding parts. I'm going to name this one triangle ABC. So what would I name this triangle? DEF. And we're going to put the similarity sign between them. Make sure your corresponding parts are in the same position. So are these 2 triangles similar? And if so, why? All right, so I know that these 2 corresponding sides are parallel. So I have 2 parallel lines being cut by a transversal. That makes my alternate interior angles congruent. Here's another transversal creating another pair of alternate interior angles. And I could even go so far as to saying that my vertical angles here are congruent. So I could pick any 2 of these. Because they are congruent, then I can say yes because of the angle-angle theorem. Another similarity theorem is the side, side, side. Okay, what do you think that's saying? It says if the measures of the corresponding sides of 2 triangles are proportional, don't say congruent. It's not congruent. We're not making a congruency statement. Okay, they are in proportion to each other. Their ratios are the same when I reduce them. Then the triangles are similar. Okay, so here's one triangle. Here's another triangle. If I know that these corresponding sides are in the same ratio as these 2 corresponding sides, so let's just say this was 2, 4, and 6. And this was 4, 8, and 12. Did I multiply all 3 of these by the same number to get all 3 of these? Yes, I did. So my ratios should be the same. I've got 2 to 4 because these 2 sides are corresponding. Then I have 4 and 8, those 2 sides, and then I have 6 and 12. All of these reduce to the same number, 0.5. So they're proportional. So again, what is my congruency statement going to be? It's going to be triangle ABC is similar to triangle DEF. Here's some other numbers that might work. Yeah, I kind of did it backwards before. Made this one bigger. Okay, so this time we're looking at our smaller triangle. All three of these numbers are multiplied by the 2 to create our bigger triangle, proving them congruent by side, side, side. Which of the following 3 triangles are similar? All right, so I've got to be able to find my corresponding parts here. Okay, so I'm going to look at my smallest sides and figure out what that ratio is. So I have 6 to 4 to 6. That reduces to 3 to 2 to 3. Now let's go to our middle sides. 9, 6, 10. So 9 to 6 to 10. I cannot reduce these 3 by anything. So obviously these are not in the same proportion, but I can reduce these 2 to 3 to 2. So perhaps these 2 are similar. Let's check the third side. Okay, this one's already out. So we have 12 and 8. So I have 12 to 8. What goes into 12 and 8? 2. But that will even reduce again to guess what? 3 to 2. So every time we get 3 to 2 when we compare this triangle 1 to triangle 2. So triangle 1 and 2, or let's name it triangle ABC, is similar to now we got to match our corresponding parts. It's not automatically in alphabetical order. If we start with A, which vertex over here matches with A? It's going to be F. If I go to B, which vertex over here matches with B? D. And then C is going to match with E. So our congruency statement is triangle ABC is similar to triangle FDE. It asked us which 2 were similar, so we could just name. But again, our matching parts, corresponding parts should match in order. Okay, and this is just showing the ratios that we already did. Now, what theorem were we using to say that they are similar? Because we didn't check the angles. Do we need to check the angles? No, because we have a theorem called the side, side, side theorem, which means all I need is 3 sides. Now, let's go back to scale factor here. Remember, a scale factor is our ratio. Okay, it's that repeating ratio. All of the sides are in a 3 to 2 ratio, so that is the scale factor. This theorem is called the side angle side similarity theorem. What do you think our 3 parts that are necessary are going to be here? What is this going to say? It says if the measure of 2 sides of a triangle are proportional, not congruent, but proportional to the measures of 2 corresponding sides of another triangle, and the included angles are congruent. Remember, sides are proportional, angles are congruent. So if we have side angle side following that pattern, then we're good. So here's an example. Here's our corresponding sides. Let's do 6 corresponds to 3. 8 corresponds to 4. Are they proportional? Let's check by cross multiplying. Remember, we go from the bottom to the top, that's 24. Go from the bottom to the top, that's 24. So yes, our corresponding sides are in proportion. Are our included angles congruent? Yes, they are. So we will say triangle ABC is similar to, match the corresponding parts, DEF, because of side angle side. Okay, we need to prove that this big triangle, RTS, is similar to the small triangle, should be named PQS, we need to go in the same order, right? Okay, so we need to know if our corresponding sides are in proportion. We know that this vertex angle is the same for both of them. Okay, so we know that angle S is congruent to angle S because of the reflex property, saying something is congruent to itself. Now let's take the left side of my small triangle, which is 4, and make a relationship or ratio with the whole left side of the big triangle. It's this whole side. This 12 is not a whole side. The whole side is the 4 plus the 12, which is 16. Okay, let's see if our other two corresponding parts are in the same ratio. We have the right side, which is 5, over, what's the whole right side of this triangle? 20. Again, we can reduce and compare, or we can cross multiply and compare. We have 80, and we have 80. Okay, so we're comparing the ratios of corresponding parts. So yes, I have side, angle, side. So I can say that triangle, now we named them differently. Again, I can start anywhere. S, P, Q, start at the same vertex angle and go in the same order. S, R, T. They are similar. Why? Because of the side angle, side triangle theorem. All right, so let's see if these two are similar. I know that these two vertical angles are congruent. I do not know that these are parallel lines. Nothing is telling me they're parallel. I don't have any markings. So I cannot say alternate interior angles are congruent. But vertical angles are always congruent. Now I just have to compare my corresponding parts. If I were to take this triangle and turn it around this way, the 9 would land on top of the 12. So those are my two corresponding parts. And the 10 would land on the 15. Okay, so I'm just going to reduce these. Again, I could cross multiply from the bottom to the top, but I can see pretty easily that 3 goes into both of these, and this will reduce to 3/4. 5 goes into both of these, and I get 2/3. So are my parts proportional? My angles are congruent, but are my parts proportional? Nope, they're not. So I'm going to say they are not similar. Okay, another example. How far is it across the river? So this is my river. Oh, kind of looks like water, not exactly. So here's our picture. Okay, we're setting up similar triangles so that the distance across the river is going to correspond with maybe a very easily measurable distance there, say between two trees or something. If I know that the distance here is 5 yards, that's going to correspond to the X yards here across my river. And then if I can walk between these two trees, cabins, something, and I know it's 2 yards, and then I can just, again, I could walk maybe 42 yards from this same tree or cabin or landmark of some sort down the river. I could easily walk that and measure it to, again, some landmark. I can find this missing part. Okay, I'm going to set up a ratio, corresponding parts. The 2 yards here is going to correspond to the 42 yards on my big triangle. I go back to my original triangle. Whatever one I put on top here has to go on top here. So my 5 yards is going to correspond to my unknown part of my big triangle. Now I cross multiply, divide by 2, and my unknown measurement is 105 yards across that river. Here's another one. If I know that these two lines are parallel, okay, then that tells me something here. If I know RS is 4, RQ is x plus 3, QT, 2x plus 10, UT is 10, find RQ and QT. So again, I need to set up a ratio here of corresponding parts. You can start anywhere. Let's start with a 10. What part of this small triangle corresponds with the 10? The 4. Okay, now I have to go back to my first triangle and choose another part. 2x plus 10. Now I go back to my small triangle and find the corresponding part to that, which is x plus 3. Okay, now get in the habit here of putting these algebraic phrases in parentheses so you won't forget to distribute. Because when I multiply here, I need to distribute that 4 to the 2x and the 10. And I need to distribute this 10 to the x and the 3. So let's distribute here. We get 8x and 40, 10x and 30. If I subtract my 8x for both sides, I get 2x over here. Now I have to move my 30. These cancel. So I get 10 equals 2x. X equals 5. Does that answer my question? No. It tells me to find RQ and find QT. So here I got to go and plug in my 5 here. So I get 8. And my 5 here, which is 10 plus 10, which is 20. So those are my two answers. Okay, so our two answers, 20 and 8. One more. Again, we know that A, B, and D, E are parallel. We label all the parts, and we're asked to find AC. So before we can find AC, we got to find X. So again, we can start anywhere. We just need to understand that we're going to set up a proportion. So I'm going to start with 38.5 over its corresponding part, which is 11. That's going to equal, go back to the big triangle, 3x plus 8, over x plus 2. Again, get in the habit of putting those in parentheses. So I'm going to multiply here. I need to distribute. So I'm going to get 33x plus 88 equals 38.5x plus 77. Okay, now if I subtract my 33, I get 5.5. I subtract my 77, I get 11. Oh, this is an x. Divide by 5.5 and I get 2. Now, that is not my answer because it didn't say find x. Okay, so don't be in a hurry and pick choice A. Make sure you answer the question, what is AC? Okay, so if x was 2, AC, I got to plug that 2 in. 6 plus 8 is 14. So my answer is D. Okay, so we'll stop there. Make sure you can use your different theorems to determine if two triangles are similar to each other or not. You do not have to relate all 6 parts. You can pick angle, angle. You can pick side, angle, side. Or you can pick side, side, side. As long as those sides are proportional and those angles are congruent, you're good. Use those to set up proportions to find unknown measures. If you can do that, then you're good.